Okay.
Mounted on the back of the unit, typically on the back side of the sleeper, on the outside, you'll find your condenser, which releases all the BTUs picked up from inside the cab to the ambient air. And we have our condenser fan and the refrigerant coming up. That's where you would find, once it comes out of the condenser itself, we have a receiver dryer on the outside of the condenser. It'll be located very close to the actual condenser. Right on the receiver dryer, you'll find another safety, a high pressure cutout switch. In the event we have abnormal high pressures in the neighborhood of 400 psi, it'll also shut the refrigeration system down to prevent damaging any of the components. While we're in the back here, here's our actual, all the wiring and circuitry, our interface board with our microprocessor. And where you would find that, you may find it in various locations. It might be underneath the actual bunk in the sleeper itself, or in the jockey box of the truck, depending on the truck model and the application. Located on the actual control box, while we're looking at it, there is a reset switch. In the event this unit doesn't start or it shuts down for various reasons, this reset switch may pop to prevent the unit from starting up and damaging various components, which we'll talk about here in a minute. While we're in the back also, you'll notice that I have a fuel tank here for this unit, and typically the APU, where it's going to draw its fuel is off of the truck's fuel tanks themselves. So it would be tapped into the truck's fuel tank, and also have a little pump here, and it's referred to as a pulse pump. It's part of the heating system of the APU itself. And you'll notice that the pump is located very close to the fuel tank. And that's where you would want it, no more than 6 inches approximately away from the fuel tank. And you'll notice that it is at a bit of an angle. The recommended angle is anywhere between 15 and 35 degrees. If it were straight vertical or straight horizontal, that may be a problem, and your fuel heater may not run properly. It'd be drawing air, not pumping enough fuel. They're meant to push fuel, not pull fuel, so they have to be close to the fuel tank itself. Coming around to the front again. It maintains the cab temperatures, cooling, as well as heating. So we'll have a look at what provides heat in the truck cab. Thermo King decided that they would go with a heater, and the type of heater they use is an SBAR. This particular SBAR, it's a D2. It's capable of providing 7,500 BTUs per hour of heat. You can get an optional D4, which provides 13,000 BTUs per hour. But this D2 is more than sufficient for most applications. It is wired into the control system, which is also being monitored and controlled by the same controller which operates the air conditioning. Thermo King incorporated the SPAR technology and software into their own controller. Another feature of the tri-pack, it is an option, is an inverter. If the operator wanted to have a little fridge or a microwave or some type of electric AC device, appliance in his truck, he may want to go with the actual inverter. It's capable of producing, sort of supplying 1,800 watts of electrical power. Down here, I have the battery. The inverter is hooked up to the battery, and where the APU would get its power from is the truck batteries. So it's going to get its truck power from the truck batteries, and it's also going to be monitoring the state of charge of the truck batteries. So if we look at the controller here, we'll have a look at some of the features on the controller itself. Here we have a main power switch, off on. We have a mode of operation switch. What that's going to do, if you press that switch, it's going to cycle between the AC mode of operation. It has defrost here. It's not, they don't have anything connected to defrost at this time. We could switch to heat, in which the SBAR is going to run, or just operate the fans with nothing else running for air circulation within the cab. Here we have an up arrow and a down arrow. What the arrows typically are used for is to change temperature. For a higher temperature for heat, or a lower temperature typically for AC in the summertime. Over here we have a fan switch. And the modes of operation for a fan is you could have it on low, medium, high. Auto at this time is not used. It's not programmed to work on auto. Over here is our off-on switch for the APU. What that does, it enables the APU to start and run the engine. Another feature of the controller, it has a system fault. There's an actual little LED, a red LED, which will come on in the event that a fault occurred. And the types of fault that it's going to be monitoring, one, it's going to be looking at the operating conditions of the engine. If our engine encounters low oil pressure, it'll shut the unit down, we'll have a fault. If it encounters high coolant temperature, it'll shut the unit down, it'll encounter a fault. Or for whatever reason the engine does not start, when it's enabled to start and it doesn't get up and running, it'll also enable a fault. It's going to monitor the air conditioning system. If it shuts down on low pressure, we're going to get a fault. If it shuts down on high pressure, we're going to get a fault. It's going to monitor the charging system. If the alternator, if it doesn't sense output from the alternator within 2 minutes of startup, we're going to get a fault. If the battery charge level is low, if it's below 12.1 volts and there's not enough voltage to start the engine, it's also going to generate a fault. So what you'll see is if the code come up, it'll either come up engine, it'll come up AC, it'll come up battery, or it'll come up alternator to enable you to distinguish what the actual fault may be, why it would not run. If we look at the way that the coolant is plumbed in the ATV, off the top of our thermostat housing here, we have our hosing routed. It comes out of the APU, and right here I have a tank. What this tank is simulating is the block of the truck engine. So from the top of the thermostat housing, we're going to develop heat in the APU engine. It's going to be circulated up to the truck engine, through the block of the truck engine, and return to the APU again. So the truck engine will maintain warmth in the wintertime. That is another mode that you can actually set up. If you turn it on, the main power on, and the APU on, and if you set the mode for null, none of these lights are on, the APU is just going to sit there, what we refer to in a null mode. And in the winter, if you set it in that mode, what the APU is going to be monitoring is going to be monitoring the state of charge of your batteries in the truck, and it's going to be monitoring the coolant temperature of the truck's engine. If the coolant temperature of the truck's engine drops below 30 degrees, it's going to start up and get the actual truck engine up to 50 degrees. That's Fahrenheit. If the state of your batteries drop down below 12.1 volts, the APU is going to start up and it's going to get your batteries back up to 13.6 volts and it's going to shut down. So it's another feature it has is to monitor the truck coolant level and battery levels, so it'll start in winter conditions. So let's go through the operation of the unit itself. I'm going to turn the main power on and we'll see an LED light come on, and on our display it tells me it's a tri-pack and I see the temperature displayed. Right now it is at 90 degrees, nothing's happening. I've got the AC light is on, but it's not going to provide any AC with the APU off. If I cycle through in the mode, and there are no lights on as it's sitting right now. Right now it is in a null mode. It's monitoring my battery, my charge level in the battery, and it's monitoring the coolant temperature of the truck engine. If I cycle through, I can't get any fans without the APU switched on, but I can get heat. I'm switched into heat mode, and if I bump my temperature up to 90 degrees, my S-bar heater will start and run. So it'll start and run, but if I don't have the APU enabled, what it's going to be running on is the truck batteries. So it's not the best mode of operation to have the heater running in, because if you let it run for extended periods of time, the charge level in your batteries may get low. So even with the heater capable of running without the APU, it's always better to actually switch on the APU. And now we can run the heater and the APU is going to be monitoring the truck batteries. If the truck batteries run a little low, the engine will start and it'll keep the truck batteries charged. We have a system fault right off the bat. Another thing that I did not mention, if you're going to start one of these and you get a system fault and nothing happened, there is a safety switch on the inside of the compartment. Down here is engine on, engine off. So anytime you're performing maintenance on a unit, you want to have that in the off position so it will not start. Because another feature of the controller, it has what we refer to as cycle sentry. The engine will not run needlessly. If the air conditioning is satisfied, if the heater is satisfied, if the battery is satisfied, if the coolant temperature is satisfied, this engine will turn off. And it's just going to monitor the various systems that it's supposed to be monitoring. That's referred to as cycle sentry. So it can start at any time. It has a warning buzzer, but be aware that the buzzer is a mechanical device. It could fail. So anytime the switch is on and this controller is switched on, it has the capability of starting. So I'm going to turn that on. To clear the code, I just have to shut this off, the APU off, turn it back on again. The APU's on. I'm going to switch my fans to low. I have it set for 70 degrees. I'm going to put it on the AC mode at 70 degrees. It may not start or cycle the clutch because it's too warm in the room. Temperature down, lower the ambient temperature. Clutch has cycled on. Fans are running. Has reached the set temperature. It has cycled off. The inverter itself, it has, when you switch it on, what you're going to see come up on the display of the inverter is the state of charge of the battery. Right now what's reading here is 12.8 volts. And you could actually select, you could actually have a look at the input current, whatever is operating off the inverter, and your output power. And it's rated in kilowatts. So if I take this electric drill here and plug it into the inverter, I should be able to operate it. If I let this drill run long enough, because I have the APU enabled, when my voltage from my batteries drop to 12.1, the engine will start up to get the battery back up to a state of charge again. So if the operator is running an appliance such as a fridge or a TV, he could just enable, turn the APU on, run his appliances off the inverter. It's going to monitor his batteries. If his battery charge level gets low enough, the APU will start and get the battery back up to the proper charge levels. The battery's up to the charge level at approximately 13.6 volts. So he's capable of starting his truck after sitting and watching a movie for a couple of hours, for example. And that is basically the functions of this APU.